Hello students, welcome to the next session. Today we'll be discussing about the back exercise questions of chapter 12 electricity, that is page number 221. So beginning with the very first question, we have a piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If equivalent resistance of this combination is R dash, then the ratio of R by R dash is. So we are given a wire of a particular length whose resistance is capital R, and this wire is cut into 5 equal parts. These parts, 5 equal parts, are then connected in parallel. We have to find out the ratio of their equivalent resistance in parallel to that of resistance of the entire wire. That is, we are supposed to find out resistance of the wire divided by the equivalent resistance of the 5 parts which are connected in parallel. So if the resistance of the entire wire is R and it is cut into 5 equal parts, then the resistance of each of the wire. Now see, we already know R is proportional to L. Now the length is decreasing of each of the part by 5. These parts are of equal length. So likewise the resistance also reduces by 5. So this will become R by 5. So each part has a resistance of R by 5, R by 5, R by 5, R by 5 and R by 5. Now these 5 parts are connected in parallel. Remember, equivalent resistance in parallel is given by 1 upon Rp, but here it will be represented as R dash. So we can write it as 1 upon R dash is equal to 1 upon R1 so that's 1 upon R by 5 or simply 1 by R by 5 can be written as 5 by R, and this will be added up how many times? This will be added up 5 times. So this is 25 upon R, and remember this is the value of 1 upon R dash. We are supposed to find out R dash. So this is R by 25, right? Now we have found out the equivalent resistance in parallel. R we already know is R. So the ratio R by R dash is R upon R by 25, or R upon R into 25. R and R cancel, so it is 25. So our option D is correct. So the ratio is 25:1. I hope it is clear to you, students. The next question, that is the second. Which of the following terms does not represent electric power in a circuit? Remember, power is defined as a product of VI, right? Or it is the rate of dissipation of energy, or consumption, the rate of consumption of energy, or alternative formula I square R or V square upon R. So these 3 formulas are absolutely correct. So which one is incorrect? That is the A one, that is I square R. This is an incorrect representation. Coming to question number 3. In question number 3, we have an electric bulb is rated at 220 volt and 100 watt. So in question number 3, V is given as 220 and power is given as 100 watt, right? What is the representation of power? When it is operated, so when V becomes 110, you have to calculate it, how much power is consumed. Remember students, here obviously since power has to be found out, we'll be using the formula of power. But which out of the three formulas do we need to use? We have I square R, we have VI, we have V square upon R. Since no matter how much is the power, how much is the potential difference, remember the resistance of that particular material will remain the same. So we'll be making use of the parameter which are given to us. P is given to us, right? V is given to us and R is given to us. So we'll be making use of this particular formula. Why this formula? Because no matter how much increase or decrease in potential difference there is, the value of R will remain unchanged, right? So we have P is equal to V square upon R. So putting in the values, we will calculate the value of R first, which is V square upon P. So what is V? 220 into 220 upon P, which is 100. So that is 484 ohms. That's the resistance. Now, as I told you, no matter how much is the potential difference, R remains the same. Again, we'll be making use of the same formula. But this time we have to calculate the value of P. So our V is 110 now. But resistance remains the same. That is the one that is calculated. 11 tens are 11. This is 11 tens are 11 fours are 100 upon 4, which is equal to 25. So the power consumption here is 25 watt. So our option D is correct. This is option D. I hope it's clear to you, students.